Hey, what's up, everybody? Welcome to another episode of Model Monday Live. We're going to be really going for it today. I've had a lot of fun reading through the chat, reading what some of you guys are saying. Tyndall says, just searching for some decent entertainment, and I hear this is the place. Yes, you've come to the right place, Leonard. Thank you so much for joining us again this week. And welcome to everybody. If you're here for the first time, be sure to let us know in the chat. The chat, I'm sure, will give you a warm welcome. So I hope that everybody is enjoying themselves on this Monday. It was a pretty good weekend. I got to say, I got to spend a lot of time outside enjoying the beautiful weather. And a lot of time with the family and just a lot of time, sort of being healthy, sort of cheating, doing some bad eating, that's for sure. I didn't eat as well as I normally do this weekend, so I'm going to be paying for that this week, trying to work it off. But some weekends are like that, right? When summer begins, when the kids are out of school, sometimes you got to just kick back, enjoy yourself with some friends. And there was definitely a lot of that going on this weekend. So that's enough for me. Let's see here. Omri in the chat says, I'm first time modeling live. Awesome. Kadir is here first time as well. So welcome to our first timers. Let's get into it here so we can show you guys how this all works. Of course, along the way, please let me know if anything sounds out of line, if my audio sounds out of line, if the video goes out of line or anything, let me know. Manta Trip just came in and said first time here as well. So welcome Manta Trip. Great to see you in here. And Table 36, an old friend of the show, is in here as well. What's up, Table 36? All right, so for those of you who are here for the first time, today what we're going to do is we're going to go over 3 CAD speed modeling challenges. We're going to get into some Model Monday solved content. I'll show you guys kind of how I've taken on some of the challenges from the past. And, of course, throughout, we've got the wonderful entertainment of the best chat ever. I always like to remind people, whatever you can do to help the channel is very much appreciated. And some of the biggest things that you can do are just to get out there, like and subscribe. Certainly, if you're watching the video, be sure to give the video a like today on the live stream. But, get out there and maybe share and reshare. One way that you can do that is you could maybe take a screen capture of some of the work we do here today. Because part of what we do is we do grab screen captures, and you could post that somewhere, and you could say, hey, here's some good content. Maybe you haven't seen this, or if you see one of my videos, feel free to repost it on your social network. And that's how we really can leverage the ability to have a network effect, and of course leverage and hopefully grow the overall channel so we can get more and more people in here as we roll into tournament season. So be sure to get out there, share the channel, share the videos. If you see a video that you think will be helpful, throw it up on your social network. Just a simple link is excellent. And just say, hey, guys, check out this video. You'll learn some good tips and tricks from this. I also want to say that I am very thankful to be working with the crew from SOLIDBOX. SOLIDBOX specializes in putting together configuring hardware so that you can have the best possible experience from your professional CAD CAM workstation. There's nothing worse than getting a brand new workstation and immediately running into errors like this. You take your new system out of the box, you load up SOLIDWORKS, you open your first assembly, and you're running critically low on memory. That is never good. And so what the team at SOLIDBOX will help you with to avoid that is, first of all, they'll help you pick out the appropriate size hardware, the appropriate specifications for the hardware for the typical work that you do. But then they'll also go through and before they ship the system to you, they'll make some tweaks to Windows and some tweaks to the BIOS and just ultimately make sure that that system is optimized for CAD and CAM engineering. And the reason the team at SOLIDBOX is so good at this is because they are all professional CAD or CAM users. So they really know what to look for when they're benchmarking these systems, and they know how to kind of test them before they send them out the door to you. And that way, as soon as you get the system, you have the best possible experience. So if you haven't checked them out, be sure to go to mysolidbox.com. And if you and your team are ready to purchase some new hardware for your engineering team, be sure to let them know that Toby sent you, and they will absolutely take care of you. So with that, let's get into our Model Monday Live CAD speed modeling challenges. And the way that this works is I'm going to show you a 2D print, and you are going to turn that into a 3D model. And your goal is to calculate the mass of that 3D model and enter that mass into the YouTube chat as a number. That's pretty much the long and the short of it. I mean, the basic rules are that you can use any CAD package out there. As long as that CAD package can input density and give you a calculation for mass, you're good to go. You want to make sure that when you're doing these challenges, you use the specified precision that's on the prints. And the first person to enter their answer in the chat is declared the winner. Now, as far as the material density goes, you'll notice here, these are the three materials we use, and these are the two different unit systems we use. So a lot of times I encourage people to grab a screen capture of this page, just kind of save it off as its own standalone JPEG, and that way you can get back to this in the future. But really the best thing you can do is make sure you have these materials readily available with the appropriate densities. These are the default densities in the CAD system that I use. But if you're using something different, then you want to make sure that you have these material densities ready to go so that you can just immediately pick the material and begin modeling that design. I see Anti-Venom in the chat, old friend of the show. Welcome, welcome, Anti-Venom. Great to see you in here today. As far as advanced rules go, it's really just a reminder that this is meant to be fun and good-spirited. And, of course, that along the way, occasionally I will make a mistake. I'll miss a dimension or something on the print. And if that happens, we'll just call an audible real quick and make sure that we get it resolved. And then finally, in the advanced rules, the Ivan exploit is permitted and is sometimes even encouraged, depending on the model. So we'll keep that in mind as we get into Challenge 1 here. And so for Challenge 1, what I'm going to do is I'm going to show you this thing in full screen. So I'm going to flip over to a full screen view here. You're going to get your screen capture software ready, whether it's Windows Snipping Tool or Snagit or MW Snap or whatever you're using for screen capture. And as soon as I show this 2D print, we are live. We are going for it. The challenge is live. And it's up to you guys to come up with the mass of this model. And the first person to do it wins. It's declared the winner. So here we go. In 3, 2, 1, go. So what is the mass of this part? In XXX grams. What is the mass of this part? And you can see here that in the lower right in the title block, we're looking at this part using millimeters, grams for our measurements and our weight. Where material is ABS, which is a density of 1020 kilograms per cubic meter. And this model, this might be like a 3D printed model, some kind of a hex bracket. You can see here the geometry, the dimensions on this thing. A little bit tricky. Not super tricky, I don't think, but a little bit tricky. Some things to look out for on this one. Make sure you take note of where your center points are for your different arcs relative to the overall center line of the model. That should definitely help keep you out of trouble a little bit as you're attempting to turn this 2D print into a 3D model. And again, if you're here for the first time, be sure to grab a screen capture of what you see on the screen here right now. Use your, whatever Snagit or Windows Snipping Tool, whatever you want to use, but grab a screen capture, move that off to the side, because in just a moment, I'm going to switch back to the PowerPoint, and we're going to keep talking about some other things as far as tips and tricks and model building goes. So I'm going to take a quick sip of my drink here. Today I'm drinking some coffee with milk in it, and then we're going to get going. All right, I hope that was enough time for you to grab a screen capture. I'm going to flip back to my kind of picture-in-picture here. Like I said, I'm drinking some coffee today with some milk in it. Usually that's about as crazy as I get as far as sugar goes. I really try to avoid sugar. But this weekend, I was a little bit less disciplined. Had probably way too much sugar. And, if you don't have sugar too often and then you have it a lot, you end up feeling it in your joints. Your joints get kind of inflamed. Not medical advice, of course. I should just say my joints get kind of inflamed. And, you end up feeling it. You get up in the morning and you feel it right away. So generally try to avoid sugar, but this is the one thing that I tend to treat myself. I put regular milk in my coffee, and I get that little bit of sugar that's in that milk, and that keeps me going for the day. I can sustain through the day without sugar if I just do that little trick. It's probably not good that that's how I break my fast, is with that with that sugar in the morning. But Nuno says sugar is my nemesis. Yes, I've fought many battles with sugar over the years. And I think nemesis is the perfect term for that. It's like we just keep going at it. We keep going Nobody really ever wins or loses. It's just like an infinite battle between me and Sugar. All right, guys, let's take a look at some Model Monday solved action here. And what I mean by this is that we post these Model Monday episodes. We post these live episodes. People get a chance to watch them afterwards. And in this case, there was an episode a few weeks ago, Season 4, Episode 2. I'm going to go through and update all the thumbnails so that they say the season and the episode, just to make things a little bit easier when people are browsing. But in Season 4, Episode 2, there was a question that came in. And this question actually looks like this question came in from Amri, who was in the chat today. Says is there a tutorial on how to solve number 3 challenge? The angled side caused me so much trouble. And bro, I hear you on that one. I believe this is the right part. Since you're in the chat here today, if this is not the part we're talking about, let me know. But I believe this is the part that you were referring to. That was a bit of a challenge. It could be a sheet metal challenge. It could be a non-sheet metal challenge. It's up to you how you want to tackle this thing. For some people, it might be easier to do it not as sheet metal. But yeah, I mean, this is kind of a challenging model, and so I figured what I could do here is jump over to our Model Monday solved mode, which means that we'll be turning on the keyboard cam today. You guys can get a look at this keyboard and this mouse setup that I have. It's very high-tech and fancy. And we can talk a little bit about this idea of sheet metal bracket, SM bracket, that we did a few weeks ago on Model Monday Live. So let me bring up our CAD program of choice today, SOLIDWORKS 2020. Let's get into this here today, and we will see what it's like to take on a challenge like this model here, this sheet metal bracket looking model here. So, just like what you guys do during the live stream, what I'll do is I'll grab a screen capture of this. So I'll grab maybe the important stuff here, material density, and there we go. That looks pretty good. And then I'll move that over onto my second screen so that I can continue to reference that as we're going through and creating this model here. And then when it comes to the model itself, I think I'm going to do this as sheet metal. So I'm going to go new. I'll pick a template that is in the correct unit system and with the correct materials. So this is plain carbon steel. And, when it comes to modeling a part like this, that is, really when it comes to modeling any part, regardless of what CAD system you're working in, you have to kind of come up with a plan to begin with. And so in this case, I think what I would probably do is choose to create this profile first. So over, up, and over. Now, why would I choose to do it that way? Well, there's some consistency as far as the width of this model goes. So what I mean is that this 18 dimension that goes from here to here, it seems like it more or less carries through the model. It hits this tangency point here, which is the tangency point of the bracket over here in this view. So it's the tangency point of that bend. That's going to give me a nice setup to do bend outward. I just think it kind of sets me up nicely to create this model. So I think that's what I would choose as my starting plane, starting profile. When we're doing 3D CAD, it doesn't matter. It really doesn't matter what CAD system you're in. When it comes to doing 3D CAD, you're always trying to come up with a couple of things right at the start of the design. So those things that I always come up with are, number one, what's the starting plane, starting profile going to be? And number two, that kind of goes hand in hand with that. What's the first feature going to look like? The base feature. Like when I go from sketch to feature mode for the very first time, what am I going to end up with? And I think in the case of this model, I'm going to end up with something that looks like these two views kind of combined together. So it's going to come over, up, over as my sketch. And then I'm going to use that to create, basically this geometry. It'll be straight, but it'll be this geometry here. That's going to be what my first feature looks like. So that means that my starting plane is going to be the center plane that's running through that model. It'll be, basically this plane here that's running through the model. So we always want to ask ourselves, where are we going to start our very first sketch? What's our first sketch going to look like? What's our first feature going to look like after we take that sketch and turn it into a solid feature? Sometimes it's a loft, sometimes it's a sweep, sometimes it's a sheet metal. We have to kind of use our best judgment, use our experience in CAD to determine what that's going to be. But that's always the first thing you want to think about. What's my starting plane and my starting profile? Those two things go hand in hand, right? Because you're going to create your starting profile, which is your first sketch, on your starting plane. What starting plane also helps you establish is how is the model going to be located relative to the origin? And it kind of leads you into the next question, which is, does the model have symmetry? Because if the model has symmetry, then that really helps you figure out where the first sketch should be located. Should be located right in the middle of the part. It can also potentially save you time, because if you can just model half of the model and then kind of mirror it at the end, that's going to save you a lot of time. So these are all things that we think about, and again, it doesn't really matter what CAD system you're working in. Like, I'm working in SolidWorks today, but it doesn't matter what CAD system you're working in. These same tips and tricks are applicable to really all CAD systems. So starting plane, starting profile, is the model symmetric? Yeah, I mean, a lot of times on the drawing, it'll tell you it's symmetric. Even if the model isn't symmetric, a lot of times you can see that there's like partial symmetry, meaning there's symmetry to a certain point in the feature tray. So you know that you can model half of it, mirror it, and then make additional changes that turn the model into an asymmetric challenge. But maybe it starts out symmetric, and so you can at least start out by saving time, or again, at least intelligently deciding where your origin is going to be. In this case, in the case of this model here, I'll probably put my origin here. It's definitely going to be along this center line here. I don't know if it's necessary that it's there, or it could be, so in this case, that's going to leave my origin down here in this corner. Could also maybe be up here in this location. Usually what I try to do is I try to have everything, kind of going to one side of the top plane if the model's not symmetric about the top plane. That's probably why I would opt for that location instead of this location. But, there may be other questions that come into play when you're deciding where your origin is. But those are the things I think about when I'm going to get started with a design. I think I've talked enough about that, so let's get into it here. I'm going to go to the right plane because a lot of times I just try to model, the same way that it's drawn. So it looks like in this case the drawing has the geometry that I've already identified as the starting geometry, meaning this geometry here. This looks like it's on the right plane, so right. This over here is going to be the front, and then the top up here. All right, so that's how I'm going to start out. So now I know my starting now I know my starting profile, and I starting plane. I was trying to say starting location, I think, and I combined the two. So now I'm going to utilize auto dimensioning. So as soon as I begin sketching, I can immediately enter a dimension, and now that geometry is fully defined. And I'm going to create some additional auto dimensioning here. So this is 23 to the top, and the wall thickness is 3. So I could type in 23 minus 3, or I could just do it in my head. I can actually figure that one out in my head, no problem. So very proud of my math skills today. So I'm going to go here to this final dimension, and we're going to make that 130. And that's how we create the geometry for this first setup here. So you can see it comes over 98, it goes up, comes over, this is our 130, and then this is our 23 minus 3, because that 23 is going to the very top. Okay, so now let's turn that into a sheet metal feature. So we go features, and we go sheet metal. So these tabs up top here, we go sheet metal, base flange tab, and we're ready to turn this thing into a sheet metal design. And in this case, because the model is symmetric, and because it's got this kind of funky flange sticking out here that, like, I really don't know how I'm going to handle that yet. I just know that it's going to be tricky. Because of those two reasons, I think what I'm going to do is I'm going to choose to just model half of it, and then I'll mirror it over to this side when I'm done. So I'll just model this half here, and then I'll mirror it over to that side when I'm done. So that means I'm going to take my 18 dimension that I identified earlier, and I'm going to cut that in half. And you can do that right in this dialog box here. You can go 18 over 2. And then that way you don't, if you can't figure that out on your own, you can just let the software do it for you. Now, this is kind of like a thin feature in the sense that it's not extruding as a thick model. But I need to declare what the wall thickness is. So the wall thickness here is going to be 3 millimeters, and it's going to be on the other side of the design because of the drawing. Because what I said earlier, a lot of times I just like, for consistency, I like to have everything on one side of the origin, at least in the beginning. And then it looks like the bend radius is 3 everywhere except for one spot. This is kind of a weird scenario here. And I wanted to show you guys that I have the physical part, but you can see that we've got a bend radius here of 3 and then a bend radius of 5. And I'll hold this up to the keyboard cam a little bit. You can see that it is, oops, sorry guys. I forget that the camera's a little weird. But it does have this wall, this radius here is like greater than the other radius. So let me switch back to my regular webcam. There we go. See, so like there's a pretty obvious difference between those two radii. One of them's much larger than the other. I thought that was kind of unusual. You don't usually see that in sheet metal. Usually it's pretty consistent what you end up seeing, but this model was a little unique, and so that's part of why I thought it would be a good example here. So I'm going to say that I want the default bend radius to be 3 here and hit the green check mark, and then I'm going to immediately go into that base flange, and I'm going to notice that there's these 2 different bends that were created when I created that base flange. And you in SolidWorks, you can actually modify the radius for any bend that gets created when you create a sheet metal feature. So in other words, I can go to this bend here and say edit feature, and then I can say I don't want to use the default bend radius, and I can change that to 5. So I found the bend in the feature, and then I unchecked this box here, and then I input my new value for the bend radius there. That's how you can do that. And so we hit the green check mark, and now if we click on this face here, and then we look down here in the status bar, we can see that the radius of that bend is now 5 millimeters. So that's excellent. That's what we wanted. If we just want to do a quick sanity check, we could pick on this face here, and then we can see that the radius of that bend is 3 millimeters. So epic. We got what we wanted there. Non-uniform bend radii in a sheet metal challenge. Good stuff. All right, now as far as this rear section goes, we've got a full round here on the very rear. So I think I'll probably end up saving that for... I'll probably end up saving that for the end of the model after I do the mirror, because it's easy to just rip in a full round fillet if you have, all 3 faces. Right now we only have 2, right? Because the model's cut in half. So kind of save that full round for the end. And the slot, a lot of times I save my cut extrudes for the end as well. This is just kind of establishing like a consistent workflow. When you're working in 3D CAD, you want to kind of get in the habit of doing things the same way over and over again. Don't just randomly do things. It'll make it much easier for you and for your coworkers to visualize your models and to edit your models, really, if they get your models. So I'm going to save those cut extrudes for the end. So I guess that means that I'm basically ready now to move on to this kind of weird section here, where we're trying to create this bend that comes up at an angle that goes up to 7 millimeters at the highest point. It's a very strange way of defining a sheet metal design, or really any design. You wouldn't normally see that. I guess usually you would see more of like a flange length, but it's what the customer needs, and what the customer needs is what we try to provide. So that's why we do these things. So let's get in here now. We're going to create an edge flange, and whenever you do an edge flange in SolidWorks, there's some important information you need to know about. So I click edge flange here, and the first thing that's very important to know about is the idea of what's called flange position. So this is down here in the flange definition. You kind of come down here to the flange definition, and then there's a section here that says flange position. And there's mainly 3 different flange positions. Now, these ones here, obviously there's 2 more on the end here, but they're not as important unless you're doing non-90 degree bends. Now, I realize we are doing a non-90 degree bend here, but just for today's example, let's just ignore these last 2 and just focus on these first 3, because these are the more common cases that you run into. And so what we've got here, and you can actually kind of see it in the illustration of the icon, we've got this guy here, which means bend the material so that it is inside. So it's the same location as the original material from the solid flange that you're creating the edge flange coming off of. So here's what I mean by that. If we look at this model here and we go to this first option, we can see that the original solid geometry came over and came up here, and we can see that the edge flange is right up against that. It's nice and flush right up against that. The second button here means that we're still looking for where that original geometry is, but this time we're going to put the material 1 material thickness to the outside. So if I choose that second button, you can see what the result is here. We get 1 material thickness to the outside. And then the third button, I'm just going to minimize the flange parameter so you can see this third button, so you can see how it changes. What the third button does is it bends the flange beginning at a tangency point, which is exactly where the existing solid material is. So depending on how the model is dimensioned, really that's what it is. Depending on how the print is dimensioned, or depending what the customer gave to you, you have to figure out, what the appropriate flange position is. And it kind of depends on what you're building. Like if you're building an electronics enclosure, a lot of times you get the overall dimensions instead of like the inside material dimensions or anything like that. So it just kind of depends on the market that you're in and who created the drawing. There's a lot of things that it depends on. But in our case, we can see here that the view from the front is showing that the flanges are starting where the material ends, where the existing material ends. So we're going to choose that third option because that's what the customer gave us. So we're going to choose that third option there, and we can see that now the flange begins here where the material ends. It's exactly what we want. And then in the flange command itself, you do have the ability to specify an angle. So we could say that we want to specify an angle here of 60 degrees. Okay, so that's what the customer is giving us. They're giving us that angle at 60 degrees. So we're going to specify that same angle here on our flange. Now the final challenge is trying to figure out how to end the flange. And there are some clever ways of doing this. There are some clever ways of saying, like, we want this length to be a certain distance from the from the original location. But unfortunately, it doesn't really seem like any of those options are going to help us in what we're doing here. So I think in this spot, I might just opt to do it with two different features. So I might just opt to create the flange that's sticking out there, very long distance. And then I could do something like convert. There's a lot of different ways you could do this cut, right? But I might do something like convert, and then just pull this endpoint off here, create another line here, which is perpendicular, and then just merge these points together. And so what that lets me do is lets me very easily implement the customer's design intent, the 7 millimeters, to the highest possible point, without having to like come up with some weird solution using like offset from a point or anything like that. If you just go in there and you do it, with like brute force, you can still create a model that's resilient, a model that's going to stand up to changes. But you can see here that gives us exactly what the customer's asking for. So now I'm going to do S key extrude cut. This option here for normal cut probably doesn't matter if you have it turned on or off. Let's see if it gives me any flack if I turn it either way. Yeah, it doesn't matter in this case. It's a way of making sure that when you create that cut, you always get your geometry perpendicular to the material so that you can just do it normal punch to punch through the material in the flat. A little bit advanced. It's kind of like a sheet metal subject. And then I did miss one thing. I didn't want to talk about too many things at once, but the other thing that we need to do here is we need to go in and create a modification to the flange so that the flange doesn't go the full length, right? We end up 5 millimeters here in front of the flange when we're creating that flange geometry. So no problem. We'll just go edit feature here on the flange. We'll say edit flange profile, and we can actually just grab this leg here and drag it in a little bit, and then say that we want that to come into 5 millimeters. And then as far as creating your models so that they can withstand changes, maybe you'd want to put a dimension on here. Let's say we want to make that dimension 25 millimeters just so that we know that it's enough. And then there's a little trick here in SolidWorks. If you ever do create what I call a dummy dimension, a dimension that's really not going to do anything, you can right mouse button on that dimension, and from the right mouse button you can say display in drawing. So it's this. Well, it's down towards the bottom here. Let me move this up so you can see it. So right mouse button and then mark for drawing. And it's always checked on by default. If you uncheck it, that dimension actually takes on a new color. It becomes kind of like purple. And that means that when you bring your dimensions into your drawing, that dimension won't come in with all your other dimensions. So a lot of times I'll do that. Sometimes I'll actually type in like a little note here to myself, like dummy dimension, just so that I know that that's not really a dimension that's coming from the customer or even really doing anything. It's just meant to push this edge out far enough that I can cut it and I won't run into any problems later. All right, cool. So that looks like it worked out pretty good. It looks like maybe there's one other potential area that I should look at, which is this dimension here. The length of that needs to be 87. I can see it there on the print, that 87. So I'll just click on the edge and then look down here, and then I can see, yep, 87. So we're good there. Don't have to take a lot of time. Just utilize your status bar. So a couple of final features here. I'll go fillet. I'll say I want to fillet this at a radius of 2 millimeters. I will choose to mirror this geometry. So I'll go features, mirror. This is going to be a mirror about this centered face here. It's going to be a mirror of a body. This is what you want to do, especially with sheet metal. Kind of want to do this in general, but especially with sheet metal. I'll go top face, begin a sketch, orient my view, and create a slot here that's aligned with the center of my model. This slot is going to have a width here of 8 millimeters, and then some dimensions from the origin. This is another cool thing you can do is if when you're planning on where your origin is, you take a minute and kind of look at where the dimensions are on the print. Sometimes you can save yourself a lot of time because the dimensions on the print are, you know, all coming from the same spot. So similarly, we'll create a slot here running up through the middle of this part. We'll say that we want that to be, this is 8 millimeters as well. Could have done them both in the same feature. Some of you might be wondering, like, why not just make them both in the same feature? And the answer is because there may come a time where the customer only wants one of these, and I just want to make it a little bit easier for me to adjust if the customer decides that they say, I don't want that one anymore. I mean, I know you could always do like a delete face or edit the sketch, but I just think that makes it a little bit easier. And then the final feature here is going to be fillet, full round, and we're going to say this face, right mouse button to advance to the next box, this face, right mouse button, this face, right mouse button to finish. And there is our sheet metal part. And so, Omri, I hope that that was helpful to get that thing in place to help you to get that model modeled up there. I know you were doing the challenge when I did that, so feel free to go back and watch the recording after we're done live here today. But cool. And Jed, I see Jed in the chat says, nice tutorial. I struggle with that part. All right, awesome, good. Well, I'm glad that that's helpful for you as well, Jed. And as always, I appreciate that feedback. So let's go back to our challenge here that we put out for the chat today. Let's see if the chat was able to come up with the correct answer. So I'm just going to bring up the print here once again. I'm going to turn on the chat so we can see kind of what I'm looking at. Little Toby view here of the chat, and we're going to roll back a little bit, and we're going to see here that the very first answer that came in here from Gaurav, and he said 160.07. Nicely done, Gaurav. And Jed came in with 151. Victor coming in here with 151 as well. Mantra Trip coming in with 2285 and then modified 228.5. Nicely done. Bjorn coming in here with 150.99. Leonard Tyndall coming in 149.52. Nicely done, Leonard. Let's see here. We got Gaurav coming in 156. We got Table 36 148. Ryan M coming in 148. We got Juiced. Says join later, but 151 grams. Nicely done. Table 36 revising to 151. Yeah, if you guys are here for the first time, just know that there's no problem if you need to revise your answer. If you're looking at it and you're thinking, like, what did I miss? Something's off here. Why am I not getting this right? Feel free to revise. Mantra Trip says, WTF. I'm looking at all these answers, and they're all coming up with something different than me. What am I missing? Gaurav coming in 151. Nicely done. Omri coming in 158. Leonard coming in 150.99. Says, stupid arc. Condir comes in 151. Let's see here. Table 36 misses the 200 dimension. All right. Bjorn says that was tricky one, Toby. I like it. Nice. And Table 36, yep, missed one of the dimensions. All right. Awesome. 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 Cool, guys. Well, let's see what the correct answer is. So the correct answer for this challenge is 151 grams. 151 grams was correct. So it looks like the first person who came in there with 151 was none other than Jed Hightower. Nicely done, Jed. If you guys want to give Jed a GG in the chat, be sure to say, good game, Jed. Nicely done. Well done. GG. And Jed was the first one to get it. But everybody who got it and everybody who even took the challenge, congratulations. Well done. And let's get on to another one here. I'm going to take another quick sip of my coffee, and then I think we'll be ready to move on to the next one. Congratulations to everybody who got it right. Congratulations to everybody who tried it. And if you did try it and get it wrong, of course, you can always go back and try it again. And as always, if you guys have questions about these, just let me know, and I'll be happy to do some more Model Monday solved. Here we go, guys. Challenge number 2. Get your pencils ready. Get your screen capture software ready. We're going to go live here in 3, 2, 1. go. Jed says, first time win. Congratulations, bro. Here we go. What is the mass of this part in XXX grams? Note, in the black and white views, the line views, the fillets are hidden for clarity. You can see the fillets are listed there. True radius, 6 millimeter radius at 16 places. Hopefully you can figure out where they are between those different views. It's pretty obvious where they are. This is in millimeters. It's plain carbon steel with a density of 7,800 kilograms per cubic meter. You can see that down in the title block. The location of both the hexes and the circular bosses is along that 100 millimeter diameter circle. And looks like I did miss a dimension here. I'm just noticing it. It's not a big, no, not a huge deal. I think it's pretty obvious, but I have the. I'm going to zoom in on this part just for a second. I have the 10 millimeters listed here. Oh, it's not zooming in. You know what? The 10 millimeters that's listed as the width of the leg going out to the forearms, that's centered as well. Everything's centered in this thing. I mean, that's really the long and the short of it. So I apologize, guys. I should have had a little bit more center lining going on, but everything is centered. Nothing is like weird and skewed offset or anything. Everything is centered. You can kind of use your engineering intuition to interpret what I mean by that. But you can make the assumption that everything is centered as far as like those 10 millimeter legs that are going out, or the, I already mentioned the location of the hexes is on that center line. The center hex, right? The very middle hex is centered as well. That middle 40 millimeter diameter boss is centered. Everything's centered. So, like I said, I sometimes miss dimensions on these things, and I did, technically miss one there. That there definitely should have been at least like a 5 millimeter showing that the 10 rib is centered. So, everything is centered. You got to get centered in this life, right? That's how you get through life and you're happy. Just maintain your balance, maintain your centering. This model here that's on screen, I took a really long time to build it, and then when I went through and audited it, I blasted through it in like almost no time. And I was like, oh, I think I might have made this one a little too easy. So, see how you guys do on it. I got a third one set up for us today, so if we get through it quick, it's all good. Just gonna take a look through the chat here and make sure I didn't miss anything. I think I got most of what we were talking about. Cool. Anti-Venom has an exam tomorrow. All right. Good luck on your exam, Anti-Venom. All right, cool. Cool. All right, guys. Hope that was enough time for you to grab a screen capture. We're going to flip back to the PowerPoint. Just talk about some casual stuff here for a couple of moments. Oops, that's not the PowerPoint. There we go. All right, so let's chat it up a little bit here. Couple of updates for everybody. I told you guys about this last week. Let's see here. You model it and check the mass. Yep, that's it. You model it and you check the mass. So you try to take this, turn it into a 3D model, and then you enter the mass in the chat. So you come up with the mass and you enter that mass into the chat, and then if you get it right, you're the winner. You're the big winner. Yep, no problem. Thanks for that question. If you tell me how to say your name, I'll say your name as well. All right, here we go. So I mentioned this last week. I just wanted to tell you guys again. I did do a little article in Engineers Rule. If you want to check that out. Oh, it's all good, Egaz. Nice to meet you. Welcome. So yeah, I did an article last week in Engineers Rule, and if you guys want to check that out, it's a great website. You can get a lot of really nice tips and tricks from that website, just generally speaking. And then there's one that's specifically on a couple of little things I did with my computer after I got it to help out with things a little bit, help make things work a little bit better. So feel free to check that out. Nice little article there, if I do say so myself. Also, I mentioned this last week as well, but if you guys are interested at all in getting some training, let me know. I can do basics, essentials. We can do like a level 2 parts assemblies, drawing, sheet metal, weldment, surfacing, surfacing, simulation, some basics of simulation. We could do some like really high-end parts and assemblies with crazy, swoopy, lofty stuff and in-context design and multiple parts working together. We could even just do some kind of like a custom training, right? So anything that you're interested in, let me know. What you can do is you can head over to my website, TooTallToby.com/contact. Already had a few people reach out to me, and we're getting some stuff on the calendar, so I'm very excited about that, and just excited to be teaching again. I've taught over 200 classes in my career, and I really, truly do enjoy it. So I'm excited to kind of get back into it a little bit here. So feel free to reach out, hit me up on the contact page, and let me know if you or if your company, a lot of times companies have a budget for training. So, if you talk to the people at your company who maybe can make those decisions, and they say, yeah, we've got a training budget. Who do you want to bring in? And you want me to come in either in person, or we could do things online, but still live online, not like videos on demand or anything. Let me know, and we'll try to make it happen. Excited to get back into it. I gotta tell you guys, very excited. Quick power moves update here. I did get a chance to post some of these power moves. It seems like they're going pretty well. Having some fun with the thumbnails, as I'm sure some of you guys have seen. But, I mentioned this earlier too. If you're out there, if you're watching my channel, feel free to grab these and share them. Throw them up on Facebook or throw them up on LinkedIn, or just say, hey, if you guys like SolidWorks, check out this video. This is a great way to save some time. And then it kind of like gets out to your network, gets out to the next networks, and definitely a great way to grow the channel. I'm reading the chat here as I'm going through and looking at this stuff, and it's making me laugh. I'll circle back and talk about the chat at the end here. I just want to give a shout out here to Barry, to BJH, regular in the chat, who helped me set up the ability to send a file or an image. He had a great idea for an upcoming Model Monday Live challenge, and he was able to send me a photo. He was able to successfully send me a digital photo over the internet. We are very advanced here on the TooTallToby channel. So if you guys ever have anything, if you ever have a model or question or an image, if you're like, hey, how would you draw this? Hey, this would make a good video. Why don't you make a video about how to draw something like this? I'm here for you guys, and I love when you make suggestions like that. And if you have a question like that, I'm sure somebody else does too. In the case of Barry, he said, hey, this would make a great challenge. He just saw something, around in the real world, and he said, hey, this would make a pretty cool challenge. This looks like it would be kind of a challenging part. He sent me a picture of it, and we're working it into a future episode here. So, this is a pretty cool thing, and if you guys want to ever send me anything, feel free to send it right through that same contact page, right on my website, right on the contact page. And finally, I just wanted to mention that I do have some new merch coming soon. I know the merch page is down right now. I'm actually test driving one of the shirts right now. So I have a TooTallToby shirt on right now from the new batch, and trying to make some adjustments, come up with some new designs. But we are going to have some new merch coming soon, so be on the lookout for that. I know right now the merch page is down. I apologize. I know there's still some live links to it. It is down right now, but we'll get some new merch coming out. We'll do a new photo shoot with me and all my roommates who all look exactly like me, and we'll definitely have some fun with it again. All right, I saw a bunch of the answers coming in already. I saw none other than Tim Z. Tim Z is in the chat, guys. SolidWorks World Champion of official Model Mania. Tim Z is in the chat right now. That's amazing. So I saw a bunch of answers were coming in. Nice. 5 Lax says, here, I'll show you guys this. I'll bring up some of this chat here. We can read this together. 5 Lax says, I've been rocking the sweatshirt for the last year, and I need some new swag. That's awesome, man. I'm gonna get you all taken care of. We're gonna upgrade the quality a little bit. We're gonna make sure that the experience is amazing, and we're gonna definitely get that all posted soon. Grub says, man, should have went slower. Just kept missing dimensions. Yep, we've all been there. No worries on that one as well. And let's see here. All right, cool. All right. I think we got everybody here. Victor also forgot the fillets. Forgot the fillets. Yeah, been there. All right, let's see what we got here as far as our answers that came in. So I saw Juiced here came in 625 grams, all in caps. I love it. It's perfect. Tim Z 657.5. A little bit different answer. Victor coming in 617, another slightly different answer. Gurab coming in here 638.24. MLC CAD coming in 625. We got Jet Hightower coming in with 761, a little bit higher than some of the other people. Sorry guys, couldn't resist. Let's see here. We got Cam Smith. What's up, Cam? How you doing? Former Model Mania champion, former champion on TooTallToby tournament. 625. Gurab revising to 625. Victor revising to 625. Tim Z revising to 625. Bjorn coming in here at 638. Jed sticking with his he's even going up even higher there. 761? No, 770, going up even higher. All right, and Bjorn revising here to 625. And Table 36 coming in at 690. So let's see here. What is the correct answer on this one? The correct answer is 625 grams. So very nicely done to Juiced. I think that was within like 5 minutes of me posting the image. So very nicely done, very fast. Well done, well done. Congratulations to Juiced. If everybody could please give Juiced a GG, a good game in the chat. Very nicely done. Congratulations, Juiced. Very nicely done. Alrighty, and while you guys are coming up with those GGs in the chat, I'm going to flip over to full screen, and we're going to do our third challenge today. We're doing 3 challenges today, because it's Monday. And Victor says, variable pattern? Yeah, there was a few different ways to handle that one. Variable pattern, move face. I did it originally a move face, and then the second time I just did it with one big clunky sketch, and that was way faster. All right, here we go. Final challenge coming up here. Get your screen capture software ready in 3, 2, 1, go. So here we go. What is the mass of this part in 0.xxx pounds? That's right, we're working in IPS, inches, pounds, seconds. Material is 1060 aluminum alloy, which has a density of 2,700 kilograms per cubic meter. And we are modeling this thing in inches and trying to come up with the mass in pounds. There is one tricky element of this design. You can see that on the isometric view, I threw in a note that says angle touches here. So in order to figure out that where that angle is and how that angle goes down to the front of the part, you're going to have to figure out where to get it located on that circle. And that is the main trick to this model. So just make sure you have a plan for that, and everything else should just fall right into place. Barry says, IPS, no. No. We did an official poll last week, Barry, and we found that less than 5% of the TooTallToby viewers enjoy IPS. So we got to still throw it in there once in a while. I think I'll probably start doing full episodes where it's all metric. Maybe like every 5 or 10 episodes, I'll throw in an IPS model. Still very popular here in the States. Still very popular amongst tool makers. There's a lot of tool makers here in the States that do everything in inches. And so when you send them models in millimeters and they make little changes, you get them back and you're like, what is this? Why did they move it 2.387215 millimeters? So strange. It's because they moved it like a 60th of an inch or whatever. Alrighty. Hope that's enough time for you guys to have done your screen capture so that we can continue on with our presentation today. We're going to go back to the PowerPoint and we're going to see what we got here for our final section. We're going to do one more Model Monday solved, I think, just to round out the episode today. I got a feeling we're going to go into just a smidge of overtime, depending on how fast you guys get this final thing modeled. But while you're working on that, I figured I would just rip through this model here. And, the first model that we did, I really explained everything, really, went into detail. This one I'm going to go just a bit faster. But I wanted you to, just again to see kind of what I'm thinking as I go through and work on a model. You know, these are the thoughts that go through my head, and it's always, you know, it always starts out with the same idea. And it doesn't matter what CAD system you're in, it should always start out with this idea, which is, if I'm going to create a model like this, if a customer has this, or if it's a, you know, it's a napkin sketch, it's a part that goes between two other parts, and so we have to kind of create that bridge between those two parts. And a lot of times you and your boss, your coworkers, you kind of napkin sketch something out. You know, like if it's got the circular hole up in the top, it's got the angle there, it's got to have that fillet because it needs to clear those other parts that are in the machine already. You know, whatever it is, you kind of napkin sketch something out, and then you have to draw it. And so you have to decide where you're going to start with that design, where the origin is going to be, what makes the most sense. And so I think for this model, you know, looking over this whole model, and a lot of times I'll end up, you know, I look at the 3D view, but then I also look at the 2D views. You know, it's going to maybe be this shape here, either from the side or from the top. That might be my starting profile, and maybe I'll just drop my origin down here because I have the 2.5, I have the 2. Like, it looks like a lot of dimensions kind of come from that location, so maybe it makes sense for that to be my starting profile. Maybe I could even make this whole shape here, this whole kind of like L shape, as my starting profile. You know, then, okay, let's say I did that. You know, like, you want to kind of think through this as a thought experiment. Let's say I did make that entire L shape as my starting profile. Where's the origin going to be on this plane? Well, there's part of me that wants the origin to either be here, you know, just so it's down in a corner, or maybe even here. You know, this rib is centered, this hole is kind of acting like an anchor point. Maybe it makes sense for the origin to be located there. So, all right, well, what does that mean to the rest of the design? I guess maybe what that means is that I would go maybe 1.75 in this direction, and then maybe 1.25 in this direction. So if I make that L shape, maybe that's how I, you know, end up extruding that L shape in the two different directions. You know, these are things that you start to get very comfortable with over time. You start to, it almost becomes like second nature, where you don't even really consciously have to think about it. You just jump in and you start modeling. But certainly when you're getting started in any 3D CAD system, you want to think through, you know, you want to kind of follow through this workflow and come up with a methodology that's going to help you to create your geometry in a way that's going to be reliable, consistent, fast, you know, all those good things. So for this model here, you know, if you want to take a screenshot of it, if you're watching the recording, maybe you want to take a screenshot of it. You can see kind of what it looks like here. Let me get into it, and I'm going to just try to create this model while the chat is coming up with their answers for that other model. I see the chat's already coming in pretty fast here, so it's impressive. It looks like I'm racing against the chat now. All right, let's take a look here. Here we go. 3, 2, 1, go. All right, so like I said, I would start out my new part. I'd pick the appropriate units. I'd pick the appropriate materials. So this is in IPS and 1060 alloy. I can see here's the material in the tree. Here I could look at it and just make sure that the material density is correct, the 2700. So, okay, good. I got the correct material. So now I'm going to maybe go to right side view, begin to sketch, orient my view, and create that kind of L shape. So this comes over 2 inches, goes up 0.25, comes back in this direction, some amount. It's not actually defined from that direction, so I'm going to double back and add those extra dimensions in a moment. So this is going to be defined as a wall thickness here, 0.25. This is going to be defined as a height of 2.5 total. S key extrude. And then I'm going to go direction 1, that's going to go my 1.75, and then direction 2 is going to be 3 minus 1.75, or like I mentioned before, 1.25 in direction 2. So that gives me kind of like that initial shape. Now, at this point, I think maybe just to help me remain oriented as I'm looking at the challenge, I might choose to go through and just add this cut, just to kind of, you know, set myself up so that I can see what I'm working on. I think it'll just help me kind of, you know, maintain, like I said, maintain my orientation with regards to this design. So in order to create that geometry, what I could do is I could come down here at the, whatever the wall thickness is up top there, which is 0.25 again, come over whatever that gap distance is, which is 0.5, come straight down 0.25 again. And now I'm going to get into this arc. So to create the arc, I'm actually going to start at the bottom and come up a little bit. And then I'm going to come back, touch the end point, and create that arc. And that arc is going to have a radius here of 2.25. And then finally, I've got an overall width dimension here of 2 inches. And we can see that that fully defines the sketch. And so now from here, we can jump into extrude cut, and we can say through all in both directions. And that's basically like a surface cut. And the only thing you have to look out for is this arrow here, what this arrow is saying is it's going to cut away everything on this side of the model, and that's not what we want. So we want to flip that arrow, and you can do that just by clicking on that arrow. You just click on it, and it flips side to cut, and there you can see you're able to cut away everything on that part of the model. So now from here, again, usually I save my fillets to the end. I save my cut extrudes to the end. If it's going to help me just to kind of visualize what it is that I'm working on here, I might choose to come in here and just put in these fillets, like a 0.5 fillet here and a fillet up here at 0.75. You know, this is just to like help me stay oriented relative to the model. Now I've got the final challenge, which is to create that boss extrude that's kind of coming out from the top. And so to create that boss extrude, I think what I would probably do is start with the circle. So we'll create this circle here. It's tangent to the top. It has a diameter of 1 inch. So 1 inch, hit escape, hold control, pick one, pick the other, let go of control, make those tangent. Now I'm going to create my distance off from the side. Again, it's at 1.75, which is to the origin. So that means I can just make this vertical, which makes things a little bit easier. And now I can extrude that out to the distance of 3 inches. So that gives me that like circular shape up top. And now I can, again, come in here on this top face and create some of that other geometry, which looks like it's really just going to that same location. So that should just be something like this, right? Pretty simple. Again, you know, fillets, usually I do at the feature level. If for some reason you wanted to do it at the sketch level, you could do something like this. I personally would not do that. I would just do it at the feature level. That's always how I do it. Oops, I bumped myself out of the sketch. And that's going to go to 0.25, I think. Yep, 0.25 reverse direction. There we go. And now for that inside fillet there, that's a radius of 0.25 as well. 0.25. And we hit this guy here. And finally, we've got our, it's almost like a rib. It looks almost like a rib there. So what's nice is that we've got this plane that we created to begin with. It makes it really easy for us to sketch our geometry in the right location because we've got that center plane going down the whole model. So we could create a line here that comes over, comes up to this location, exactly on the front of the model. This is going to probably be a pierce constraint. Oh, no, I'm sorry. It doesn't go up to the model. It's got an angle dimension. So angle from here to here, that's going to be at an angle of 20. You know, one thing you can also do in this spot, a lot of times people forget about this, but there are times when it's pretty useful. You could go smart dimension from here, you know, to this line, but you can also just click on the endpoint of your sketch line. That gives you these like invisible arrows or like invisible anchor for an angle dimension, and then you can click there and you can say 20 as well. So you can go to this vertical line, but if there's ever a spot where you don't have the vertical line, it's good to know that you can get away with that, or you can do that. This should be coincident to that endpoint. And then this guy, you know, for this guy here, like what should be the location of that top line? One thing that you could do in that spot is you could just say view temporary axes and then just make it collinear here. Right, there's nothing wrong with it running all the way up to the center of the model because you're going to blast through there with that cut extrude in a moment anyway. So for the whole, so this is going to be mid plane at a depth of 0.25, and then we just finish up here with that hole. I think that's the whole model. So this face, you're going to sketch, orient the view, S key, circle, wake up the center point, pick this circle here. Diameter of 0.5 through, S key, extrude cut, right mouse button, through all, right mouse button. So that's that model. It's, you know, it's a good example of trying to think through a model, trying to decide where the starting plane, starting profile should be. And we saw that we were really able to save a lot of time by picking this as our starting plane. That gave us, you know, the perfect starting point for this rib feature here. It gave us the perfect location for the center of this hole here. I think it just really made it easy for us to get in there and to create that geometry. And we saw, you know, kind of thinking through some of the other features, some things that I, you know, normally wouldn't do, I did in that example. Like normally I would save this feature for a fillet feature. The reason I do that is it's just cleaner. It's just a cleaner way to model. You model everything with sharp corners and then you add your fillets at the end. In this case, I did do my fillets earlier, so I certainly could maybe just move these down to the bottom of the tree to make things a little bit more tidy. as far as the fillets go. And then when it comes to renaming your features, you don't want to name the fillets necessarily based on their radius. I try to avoid that because it's not a dynamic link, and instead I'll name it just based on where it's located. So this will be called like fillet front lower corner, something like that. I think is a better name than, you know, like fillet radius 5, because then if that radius changes, you're in trouble. But you know that this is always the front lower corner fillet. Cool. So I hope that was helpful, guys. And I know that a lot of people need to go. So if you need to go, that's totally cool. But if you want to stick around, we can find out who the winner is for our final answer here. And let's take a look here at this chat, this amazing chat, as we wind out our hour here together. Here we go. So let's see here. I saw some answers coming in pretty soon, pretty early. Victor got in here right away. 0.961. Nicely done, Victor. MLC CAD right behind him. 0.961. We got Tim Z coming in 0.96. He says, I don't care if it says 3 place. I'm just going to do it as 2 place. That's just how I roll. We got Cam Smith coming in 0.99, Gurab coming in 0.961, Bjorn coming in 961, Cam revising to 0.961, Jed Hightower 0.966. He's going for that extra little 0.005 pounds. Neil coming in here 0.96, nicely done. Frank coming in 0.961, and Victor said that was very helpful. I've had to do construction lines before for that. Yep, for sure. And Jed revising 0.961, and Manta coming in here with 0.980. Cool. Well, very nicely done to everyone. Let's see what the correct answer is. The correct answer is 0.961. So I think that one's going to go to Victor. So let's be sure to give Victor a GG in the chat. Very nicely done, Victor. Congratulations to all of our winners today. And guys, we are getting ourselves ready here for tournament season. We're going to start setting up the bracket for the tournament here. I know I've been saying it for the past few weeks, but it's definitely coming up. So stay excited, stay tuned in. I'll let you guys know when that happens and what the logistics are going to be for it. But overall, I just wanted to say thanks a lot to everyone for tuning in today. You guys absolutely are the best chat ever. Congratulations to our winners, all 3 of our winners today. Thank you so much to the chat. Great seeing you, and please, guys, if you want to stick around, feel free. I will definitely be happy to hang out in the chat for a few minutes. Be sure to like and subscribe. Be sure to share and reshare the channel, and take different posts and videos and throw them up on your networks and let people know. And next week I'm going to be off, June 20th. I am going to be taking a week off, so I will see you guys in 2 weeks. Sorry, Cam. I see Cam put in a chat that says, thanks, Toby. I look forward to this every week. And now I'm telling you that I'm taking off next week. But we'll get back into it here pretty soon, Cam. So thank you guys again so much. You guys are awesome. Best chat ever. And I will see you guys in 2 weeks. Bye-bye, everybody.